Okay, we're just going to do a quick little introduction to the P formula. So I wrote it in its two variations. Most of the time you'll see this NPR, so a little subscripted N and R, and a big capital P. That's the typical way to write it. Sometimes though in text it is actually easier to write it as this P bracketed N of R, so it's like a function of two inputs, N and R. And yeah, so the formula is going to depend on these factorials, which we've seen before. I really do need a bracket on the bottom there. So it'll be n factorial over bracketed n minus r factorial. So just with the factorial, there's a couple of rules that we do need for this formula to actually make sense. So n greater than or equal to 0 is an integer. And r is going to be between 0 and n. So they're both integers, and we know that r is somewhere between 0 and n, basically. So it's really the only way that the formula is going to make any sense for us. So the second rule just sort of makes sure that the thing on the bottom there is not negative. We can't have a negative inside a factorial, so it ensures that for us. And then of course we only, that's also why n is greater than or equal to 0. So in calculation, like this 11p6, what we would do is just plug it in. So that means our n is 11. And on the bottom, I'm going to have 11 minus 6 factorial, which is 11 factorial divided by 5 factorial. So if we actually write this whole thing out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, divided by, as you can see, this is very annoying. 1, 2, 3, no, I can't count right now. 1, 2, 3, 4, 5. So what we'll see taking place here is a whole bunch of cancellation on the top and bottom. All of those will wipe each other out when we divide. And so what we're actually left with across the top is the remaining 6 numbers. So the remaining R numbers. And so we could calculate that if you like. 6 times 7 times 8 times 9 times 10 times 11. And so yeah, so we'll get 3, 3, 2, 6, 40. Lots of different calculators have different ways of calculating this, so it's not really a universal formula that you'll find in there. It really does depend on the calculator. Like I have 2 calculators in front of me. One of them has a little button that says PRB for probability. Counting and probability go hand in hand. So if I wanted to access these functions, I'd actually have to find them inside of this like probability option. Most scientific calculators will actually get you to type it in as something like 11, so the n number first, and then you're gonna probably have to access using either shift or second. You'll have to get to that p, and so it's probably buried somewhere, or maybe NPK. I think mine is mine's NPR. Don't know what that's going to be. It could depends on what your calculator is. And then the 6. So you're still going to type it in sort of left to right, but you should get the same answer by doing this formula. So I wonder if the one on the right is going to do that for me. Yeah. Ugh. Okay. So for B, I can plug that in, but this one's going to have really nice cancellation. So we can actually do this one without too crazy of a time. As long as we don't try to actually write across the top all of the 2021 numbers. So what I'm going to have is 2021 factorial divided by 2021 minus 3 factorial. So 2021 factorial over 2018 factorial. So remember, factorials cancel. So if I actually try to write all of this out, 1, 2, all the way up to, want to make sure I can see that cancellation. So I'll do the 2018, 2019, 2020, and 2021, and divide by, along the bottom, it's going to be everything up to 2018. and cancellation, of course. And we're actually just left with the product of those last three remaining things. And you work that out, 2019, 2020, 2021. It's a 8 billion and something, so it's quite large. Yeah, so that's our number there. It's pretty huge. This formula is super useful in counting. So you're going to see this used quite extensively. If you just go and have a look at the applications, it's really closely tied together. You can probably figure out maybe how it's used by looking at the way that we draw those like slots for something, then something else, then something else. Especially if it's a scenario where you are removing objects every time you choose something. So it's one less each time. It's going to really come into play. Okay, so the second question and the last question that we're going to do is a little equation, a little manipulating these guys. So I'll have NP3 equals 210. And so yeah, so to try and solve this, what I'm going to do is expand the NP3. So using that formula at the top there, so that's going to be n factorial over n minus 3 factorial equals 210. So if you kind of got a feel for this, it should just leave us the last three terms, or the last three sort of product pieces. But if we do write it out with the expansion, it'll be 1 times 2 times 3 times all the way up to, it's going to include the n minus 3, an n minus 2, an n minus 1, and then finally n. And then on the bottom, it's going to be 1, 2, 3, all the way up to n minus 3. And then, of course, all of this is going to cancel out, leaving us with just those last three terms. Now, I could totally expand this and simplify it and get a third-degree polynomial equation. Yeah, I guess I might as well do that. A little review since it's nearing the end of the course. You're probably going to need to look at that stuff again. You could probably figure this out from the fact that these are integers and it's a product of 3 integers. You're pretty quickly going to surpass 210 when you try this. So you probably shouldn't have to like try very far for an n value here, but let's do this the old-fashioned way. Expand and simplify. So what I'll have there is n squared minus 3n plus 2n is 210. And so that's going to be n cubed minus 3n squared plus 2n minus 210 equals 0. So yeah, we'll go through and try and figure this out. So if you remember factoring these, so my factors of 210 are 1, 2, 3 definitely goes into it. 4 does not. 5 does. 6 does, because 2 and 3 do. 7 does, because 7 goes into 210. 4 doesn't go in, so 8 won't go in. 9, nope, 2 plus 1 is not divisible by 9. 10 definitely does. 11, no. 12, no, because 4 doesn't. 13, there's no fun rules for 13, so I'm just going to check. No. 14, I think probably will, because 7 and 2 do. So that does make sense. 15, 3 and 5 do, so 15 should. And actually 15 times 14 is 210, so I've hit my middle point. So the next one would be 21, 7 times 30, 6 times 35. Running out of space here. I'm certainly not going to try all of these. Yeah, so 35, 5 times 42, 3 times 70, 2 times 105, and 210. So yeah, a huge number of factors. But keep in mind, like, again, you don't have to do all the work I'm going to do. These are consecutive numbers. You can probably find it in this set. But yeah, like let's try plugging it in. N equals 1. Nah, it's not going to be 1, right? We get 1 minus 3 plus 2 minus 2, 10 is not 0. N is 2. 8 minus 24. That does not look like 24. Plus 4 minus 2, 10 is definitely not 0. It's 2 negative. N is 3 is 27 minus 27. And yeah, 2n minus 210 isn't going to work. Minus 6 minus 210 plus 6. Nope. 4. No, there's no 4. So yeah, we'll keep trying. The answer it's going to be 7 if we actually plug it in. You'll see that. So not 7. I'll do 7. 7 to the 3 minus is 343. 3 times 7 squared is 147. Plus 14 and then minus 210. So yeah, that looks good. I'm not totally sure. I'm just going with the fact that the numbers are sort of close-ish, but I guess I should actually calculate it. Yeah, so that's our 0. So yeah, total review here. So I know that I can take n minus 7 out. And if I do that, this should hopefully work out. So bring the 1 down. Remember, those are the coefficients of the polynomial. The n cubed minus 3n squared, etc. So multiply and then add. Multiply by 7 and add. Multiply by 7 and that's positive, so we are good. And so what we have is n minus 7 times n squared minus plus 4n plus 30. And I'm pretty sure you'll find that that doesn't factor if you try it in the quadratic formula. Yeah, so our only solution here is going to be n equals 7. So I should say actually more than doesn't factor. It doesn't have solutions specifically. So yeah, so I just did a lot of work for the sake of reminding you of something that was done way earlier in class. You probably could have figured it out, the fact that we have these 3 consecutive numbers, right? N and minus 1 and n minus 2. The only possibility in here that's 3 consecutive numbers is 5, 6, 7. So you might have been able to figure it out from that right there. You also probably could have just tried values of n in here that have to be integers and pretty quickly deduced it. It would have been a lot faster than the work I just did. So yeah, so that's kind of what we can do with this P formula. It's really good for counting applications.